Hi everyone. In the last video, we learned how to create a simple decision tree to predict the type of car based on horsepower and seats. In this video, we'll learn how to use a real-world dataset to train our decision tree classifier. This dataset can be found on Kaggle, and it's called Titanic, Machine Learning from Disaster. This dataset is pretty simple for beginners to use, and the goal is to use the given features to predict whether a passenger would have survived the Titanic or not. There are many useful features, but to start, we'll use the following features. P-class, which is the ticket class, and SIB-SP, which is short for the number of siblings or spouses aboard the Titanic. We'll use these as they are numerical features and we already know how to use them. Other features, like the embarked column, for example, are categorical. Some features like age and fare have missing values. We'll learn how to handle both of these later. In order to use this dataset, you first have to download it by clicking the download button right here. Do this for train.csv as well as test.csv. Then, if you're using an online IDE like Google Colab or Replit, you will have to upload the files in order to use them. If you're using a local code editor like Visual Studio Code or PyCharm, you'll have to move the files to the specific directory that you're working in. Once you've done that, you will need to install Pandas, which is a data analysis and manipulation tool for Python. If you're using Google Colab, then Pandas is already installed by default. But if you're using a local code editor, an easy way to install Pandas is by going to your terminal or command prompt and using the pip package manager, as shown here. Once everything is installed, we're ready to start coding. So first, we'll import the necessary libraries. So the first one is Pandas. To import Pandas, we'll do import pandas as pd. And when we import Pandas, we usually create the alias pd. This isn't necessary, but most programmers usually use this alias. If we do this, we can use pd instead of having to type pandas throughout our code every time. After importing pandas, we'll import scikit-learn. We'll do from sklearn import tree. This tree module contains all the functionality to create decision trees. In order to use the data, we need to be able to read it. This is done using the read CSV function that Pandas has. So to do this, we'll create a variable called trainDF. df is short for data frame, which is the name of the object that Pandas creates when it reads a dataset. So we'll do trainDF equals pd.read CSV. Inside read CSV goes the file name. In this case, it's train.csv. CSV files store values separated by commas, and using those values, Pandas is able to construct a data frame that is kind of like an Excel spreadsheet. Next, we can view the first few rows of the dataset by using the head function. So let's run this, and then let's add a new line of code that says trainDF.head. Now, if you're using a notebook-based platform like Google Colab, you don't need to use the print function, and if you run it, it'll look like this. But if you're not using a notebook-based platform, or for other IDs, you might want to use the print function if this doesn't work. Next, we need our features and labels list in order to train the model. So first, let's create a list called feature columns. Feature columns will contain the names of the columns of the dataset that we want to use. And like we already discussed, we're going to be using P-class and SIB-SP. So let's create a list called feature columns equals P-class and SIB-SP. So these are the two features that we'll be using to train our model. Okay, next, let's create a model, or actually, let's create a variable called trainx that stores the values of only these columns. To do that, we'll create a variable called trainx equals traindf. And inside brackets, we'll put feature columns. So this line of code will get these two columns, p-class and sib_sp, from the original dataset, and we'll copy them to the variable trainx, which will be used to train the model. This runs without any errors, so we can move on. Let's create a variable called trainy, and we'll set this equal to the column survived, because that's what we're trying to predict. Traindf, in brackets, will go survived. Now that we have trainx and trainy, we can train our model. So this time we'll just call our model CLF, which is short for classifier. So CLF equals tree.decision tree classifier, and then we'll call the fit function, which is used to train the model. So CLF.fit train x train y. Now that it's trained, we can test it on the testing data. To do that, we'll have to read the testing data, use the features, and predict using those. It's essentially the same process as how we processed the data for training. So we'll create test data frame just like we did for the train data frame. So we'll call it test df equals pd.read csv. And instead of train.csv, this time we'll do test.csv. We'll use the same feature columns to create test x. So test x will equal test df, and inside brackets we'll still go feature columns because we're using the same features. Finally, we'll call clf.predict. We use the predict function to test the model on the testing data. So clf.predict test x. And we'll print this using the print function. It looks like a lot of ones and zeros right now because 1 represents that the passenger survived and 0 represents that they didn't. So that's how we can use a real-world dataset. The model's performance is likely not very good right now, but the main focus of this video was on how to use the dataset. In future videos, we'll be using the same dataset to learn how to handle missing values, categorical variables, and feature engineering, all of which will improve the model's performance. So that's it for this video, and thank you for watching.